folks, this is Jennifer. Today we will talk about LeetCode 130 surrounded regions. The question is, given a matrix board, change all O's that are completely surrounded by X to X. So let's go through example 1 first. Here is the input matrix board with X and O's. We can imagine X spots representing Army X soldiers. And we can imagine O spots representing Army O soldiers. Obviously, this Army O soldier on the border can freely escape because he is already at the edge and can escape beyond the boundary. And then I marked the letter E to indicate that this soldier can escape. Those Army O soldiers surrounded on all sides by Army X soldiers have no choice but to surrender. To save their lives, they must change their identity to become soldiers of Army X. This means that only this Army O soldier who can escape can maintain his identity as Army O soldier. So this question is kind of asking, the soldiers of Army O on this board can escape. If yes, they can maintain their identity as Army O soldiers. Otherwise, if they cannot escape, they can only surrender and change their identity to become soldiers of Army X. Let's go through another example, example 2. Here is the input matrix board with X and O. We imagine X spots representing Army X soldiers. We imagine O spots representing Army O soldiers. You can see that Army O soldiers on the border can freely escape as they already at the edge and can move beyond the boundary. I marked the letter E to indicate that soldier O in this position can escape. Those Army O soldiers surrounded on all sides by Army X soldiers have no choice but to surrender. He must change his identity to become soldier of Army X. Like I said, this question is kinda ask whether the soldier of Army O on board can escape or not. If he cannot escape, he must surrender and become Army X soldier. If they can escape, they maintain their identity as Army O soldiers. Let's summarize the solution. First, we check boundary positions for escapable Army O soldiers. If O found, mark E to show this Army O soldier can escape. From E, use DFS to find connected Army O soldiers. If O found, mark E to show this Army O soldier can escape as well. Finally, we check the entire board. If we find O, it indicates that an Army O soldier cannot escape from that position. We then change O back to X to show that those soldiers, they can only surrender and change their identity to become soldiers of Army X. If we find an E, it indicates that an Army O soldier can escape from that position. We then change E back to O to show that those soldiers can maintain their identity as Army O soldiers. Alright, let's dive into the code. We first check the corner case. We check each side of matrix boundary for Army O soldiers, beginning with the leftmost column, and then rightmost column. We found an O, so we dive into DFS. Inside DFS, we check corner case first. We use DFS to find connected Army O soldiers. If a neighboring position is not O, we don't search deeper but return. We will mark E to indicate this Army O soldier can escape. We use DFS to search. You can imagine that after DFS from this E position, we can find those two connected Army O soldiers. We have already checked the leftmost and rightmost columns of the matrix boundary for Army O soldiers. Now we're checking the top row and then the bottom row. So this means we have thoroughly examined each side of matrix boundary for Army O soldiers. At the end, we use 2 for loops to examine each position on this matrix board. If we find O, it indicates that Army O soldier cannot escape from that position. And then we change letter O back to X to show that those soldiers, they can only surrender and change their identity to become soldiers of Army X. If we find an E, it indicates that an Army O soldier can escape from those positions. We then change letter E back to O to show that those soldiers can maintain their identity as Army O soldiers. Alright, I hope you enjoyed this video. If so, please like and subscribe. Thanks for watching. I'll see you next time.